I am extremely happy to welcome you all for the 8th session on computational intelligence. In the race to gain new customers or increase market share, companies are constantly developing and introducing new or improved products. Sometimes they are successful and sometimes they are not. With the vast selection of products available in today's highly competitive global marketplace, businesses must provide high quality products that consumers want to buy at competitive prices. Properly implemented quality engineering tools and technology can have a huge impact on product cost and quality and on the organization's bottom line. Therefore, quality engineering consists of analysis, methods, and the development of systems to ensure products or services are designed, developed, and manufactured to meet or exceed the customer's requirement and expectations. Today, we have organized this session to explore quality engineering and its concepts. It gives me great happiness to welcome the resource person of today's session, Engineer Paul Wesley, Test Lead, Oracle Technologies UK. Paul Wesley is a graduate in Information Technology from Karunya University. He has 10 plus years of experience in software testing. He started his career as a software engineer in the year 2010 with Wipro Technology, with product testing in the retail industry, Best Buy US and Best Buy Canada, spanning for a year in Chennai. Moving from a traditional tester to automation using Selenium in the year 2011 with 1800 flaws. This defined the scope, later paving way for the financial services industry with R.R. Donnelley, one of the largest printing companies. He was wholly responsible for the quality of 3 projects and heading a team. After delivering for 5 plus years, sparked for a change and moved into core banking services with UK's largest bank, Lloyds Banking Group, and transitioned from a traditional software tester to quality engineer, leading to transformation to digital age with Wipro Digital for the bank in varied substreams, mortgages, open banking with the Lloyds Bank, Halifax, Bank of Scotland, Master Bank credit card, and currently handling a new accountancy software package for Lloyds as lead tester and test manager to ensure latest processes, testing techniques, and tools at all phases of product development. We are very happy to have you here for the session, Mr. Engineer Paul Wesley. Now I hand over the session to you, please.
Thank you, ma'am, for this wonderful introduction, as well as the opportunity for this time. Hope everyone is doing well. Very good evening and good morning to anyone who is joining abroad. Without further ado, we're going to see some concepts on quality engineering and what kind of, what is the need and what do we need to do in this new age, digital age, which we are in, and how we can actually improve from the traditional software testing and moving on to the quality engineering where the world has headed to. Let's dive down into those topics. First, let's understand what's the agenda for the meeting, and what we are going to see is what is quality engineering, why and what is the need behind it, and what is the difference between the software testing concepts or the traditional methods, and how did we evolve into the quality engineering. What is the recent software development trends and where all we could apply these concepts of quality engineering, and how we can actually ensure that the quality of the product meeting to the business needs, and how we can actually provide the business opportunities with much more rigor due to the fast-pacing technology changes that we have in today's world. And how can we achieve, and what are the tools that we currently use. This is personally from what I've experienced, what I've used, but I've also collected few samples, open source tools that I could see that people are using across in different projects, So in case you are trying out with different methodologies or tools, it's always it's a learning experience to actually use those tools and understand how better we can use and improve the way that we do. And finally, in case you have any questions, you can feel free to write down or in the chat window, or in case you want to stop me, feel free to actually unmute and then ask of a question. I'll be more than happy to actually assist you with. Let's understand what quality engineering is all about. So we've understood software testing. I'll dive down into that topic as well, but more than that, the importance that we today are going to see about the quality engineering principles. So what is quality engineering? It's kind of a discipline of engineering that creates, implements strategies. So software testing was just more involved into the testing front of a particular product, finding the defects or finding the errors, logging them into the different tracking tools and managing them in a different way. But when it comes to quality engineering, it involves in all phases of product development, right from the envisioning phase to the delivery phase, and continuing on to the maintenance where the project actually survives, and how we could learn from all the learnings that we had encountered over the phases, and how we can actually evolve in the next projects or in the next iterations of that same product. It also ensures to address the quality attributes. One is the availability of the software or a product, security, safety, reliability, and performance. So we're going to see all of these quality attributes in detail a little bit further down in the topics. Why and what is the need? So in the years of 10 years of quality being my focus, the things have shifted from the waterfall era. So the projects initially were purely waterfall. So you sit down, you envision, you create the solutions, then you make sure that the product is going to work. Then you start building it. Sometimes they build a prototype, sometimes it's not, sometimes it's the end product. Once they come to the end product, they have very limited time for testing, and then they don't focus it at all. And they give very short duration for it. When people find faults or when people identify a certain problem with the solution, they go back to the drawing board, which is quite late at that moment, and they have to redo the entire process again of redeveloping the entire structure, whether their integrations would have gone wrong because of this sudden change. All this could impact in the product being delayed for a very long time, and also the cost being the primary focus for any product to get going out due to a business. It could become a bigger problem on the long run. So they might be shedding out a lot of money on it, and once they've launched, if they actually differ from the quality that they were supposed to actually ensure because of the shortness of time, there could be problems of litigations later on, and it could have related in potential risks of launching the product itself. But then came the shift left era, wherein they thought, okay, let's include the testing in one phase before, or like phases before that we actually envision the product on. So they started to incorporate the testing aspects in every aspect of the place, but it ensured the quality was there, but it didn't involve or in the process of improvement on the long run. So it was kind of like there midst of all the necessary processes that were already in place, but it didn't help them in a different way. What quality engineering brought in was it involved every single one of that team. So earlier the projects were run by massive teams. Now everybody started to become to work in silos. So what is a silo? We're going to see that, but silo would be more in terms of like, so you have 10 people working on a software that could be shipped out. So they start working from the analysis phase, from the inception phase. They design it. There'll be solution architects. There should be developers, testers. Everyone will be involved, and they will also look at a quality aspect at every level. So from the solution architect level, they would look at their aspects. If from the business analyst level, they will look at the business journeys. From the user experience level, the testers can look into it, and also with the user experts, kind of like the UX designers, they'll also look at from the quality aspects whether we could improve the process by doing some kind of testing or methodologies that would improve the process. So in tandem, it becomes united a force as one silo. So this becomes like tiny silos working together. It could be one single product or it could be multiple products. Why do we need to test the software in today's trend? It is changing, it is evolving, and in the recent year World Quality Report, they say the focus has been shifted. It is more towards the customer satisfaction rather than the actual inbuilt functioning of the software. So users, based on the usage, how the businesses could grow, and how it could actually cater to the business improvements or the business models or the business goals that they actually want to contribute towards. So that's where WQR actually put it. And since we are focusing on the customer experience, we also have to ensure that we send the product faster to the market, because there are like plenty of companies, and as mentioned in the intro, today's fast-paced changing world is expecting a market product in a very short span of time. It could be within an hour they want to see a change, or they could want to have multiple products of the same fashion, see, compare between these products and choose the better one. And it also involves the collection of great amount of data. I think engineer Jerin, I think he covered about the data that we build using the business intelligence. Yeah, that plays a part, because we study all of that information, collect them, try and build what we want to do with that data science, and use it to make and ensure a better product over the time, over a period of time. And DevOps is also a part which has come into existence now. It's been there, but now development and operations have come joined together. They want to improve the product delivery and deployment of any product that is around the world today. They want to deploy using artificial intelligence, learn something from them, and then use it on the long base that we are going to see. Let's move on to see few issues that crept into our world, and it is focused mainly because there is software testing in place, but still it failed in certain aspects, because you wouldn't be covering every aspect at the last minute. Once a product comes into picture, it has to be based out. It should be ensured at the envisioning stage, or where you actually have an idea. You need to put some thoughts into it. You should brainstorm on what the actual product is going to do and how well you can actually improve the process of delivering it. So there was a problem with CareFusion, one of the medical equipment manufacturer, and it related in a problem wherein they had to call back the ventilators because it could create a problem of suffocation. COVID-19 had created such a havoc around the world today we live in, and you know the importance of ventilators. And if this goes wrong, what could be the cause and what could be the problems that a person or a patient could suffer. Next, there are huge projects, defense projects that we hear about. India spends a lot of budget on these defense projects. Similarly, many other countries do that to protect their own country. They want to develop sophisticated weaponry, and this was one such instrument which they have created. F-35 is one of the most sophisticated aircrafts, fighter aircrafts that they built. But this resulted in a problem wherein a software bug made sure that the enemies that they targeted looked doubly. They were looked in like pairs. It wasn't possible to actually target the right one and attack. And this resulted in drawing back to the drawing board, changing their whole architecture, and then redoing their deployments.
Excuse me, Zoom needs your attention.
Just a minute, somebody needs to be admitted, I believe. Yep, I think everyone's in. Sorry, yeah. So considering a cost of the aircraft is between $94 million, and if you want to go to the drawing board, there would be orders of these aircrafts readily from different countries or different defense systems. They are looking for these aircrafts in time. But if this is going to take us back to the drawing board, you're going to restart on the entire journey, which relates to splendid costs as well as expanded timelines. So this could relate into late delivery of their entire products. Let's go into another one. So we recently saw, last week we saw how NASA and SpaceX launched an aircraft into space, and they took the persons or the astronauts to the space station. This was something which happened in 1999, but this is something very silly, but it made sure that this created a huge problem that the entire project went to a failure. This is nothing but, we all know that NASA is based out of the United States, but they had their engineers from all over the world. And one such incident happened wherein the coding was done with a different metrics, which is understood by the United Kingdom developer, but it was not understood by the system because it was developed mainly from the US based. So the metrics are completely different and the units were different. And I'm not so sure how they missed out, but this created in a complete lost in translation, and the product actually crash landed on Mars. So they lost the product, and this would have been millions and millions of dollars worth of money. And Tom Gavin, one of the NASA's Jet Propulsion Laboratory head, mentioned that people make errors. The problems was not the error, it was the failure of us to look at it end to end. So we need to look at it from an end-to-end perspective. So from the start till the end, where all we could apply quality insights, how we can actually have improve the reporting, how we can actually improve the way that we handle those errors or risks, or whatever be it, whatever is being called out, it needs to be taken care by everyone at every point in time, and we cannot point one person for the error that has happened. Now comes to a different level of areas. So we saw about defense, we saw about the aeronautical space. We are going to see something about the banking sector. So the banking sector deals with your money and my money, and if they don't manage it properly, or if there's any standard problem of security or failures, you're going to see a huge slab of fine which is going to fall on you from the regulator, which could be the person kind of like the Reserve Bank of India, or like the banks of England, which is going to define certain rules and guidelines for any bank to actually function. So if you're not going to provide proper service to your customers, you're going to face huge slabs of fine. Next comes in the year 2020, we have stepped into a place wherein our privacy matters most. So what kind of personal data that you actually store in any software or any place on your laptops needs to be secure. And if the company or the product that you have looked at or bought from is not able to manage your data properly, they're going to lose out on the customer base. They're going to lose out on their reputation over a period of time, and they're going to end up in huge scams, or they're going to have a loss of data, which could create huge slabs of fines on them from the government or from the public litigation. So in Facebook, again, we had some similar concerns. We all saw on YouTube how the founder of Facebook was questioned by the US Senate. So those are things which related to how the privacy has actually taken a picture. Earlier, it was just the quality of a product, but now it depends on how a customer feels about a product over a period of time. Next comes performance issues. So Lloyds is one of UK's largest banks, and they had a problem wherein people were not, millions and millions of people were not able to log in on January 1st, and they have around 20 or 16 banks under them. So they're not just one bank, it's a group of banks, kind of like a State Bank of India. And none of the banks were able to log in. The customers were not able to log in, and this resulted in a bank-wide reputational risk. And this brought angry customers onto Twitter's, Facebook, and they started to post about the customer problems that they faced during the login. And this was not for just 1 hour or 2 hours, it was for more than 9 hours, which resulted in a bigger problem for Lloyds to actually rethink about how they handle this performance issues. We saw about the shift left, and why did we move to shift left? So I was talking to you about the silos that people started to work in. So it's not just huge teams now, thousands and thousands of developers working on some simpler or products. It's kind of like simple small teams, smaller teams, which could range from 7 to 10 people who are working on shippable product, a part of a product onto the live systems. If you look at Amazon today, Amazon is being the largest seller, online seller, and if you consider their deployment cycles, it's insane. So they deploy every 11.7 seconds. There's a build out there for any customer to use. Similarly, Netflix deploys codes thousands of times per day. It's not just one deployment every hour, but it's thousands. Facebook, they have 50,000 to 60,000 builds a day for just Android alone. So think of the other platforms like iOS, you have desktop, you have different versions of Facebook, and they have to meet certain guidelines in different countries, and they are deploying at phenomenal rates. We saw about how quality engineer spans and works in different quality attributes. Just to give you an idea of what that quality attributes, just a small definition. What is availability? The ratio of time or system when it can be functional, and to what point in time, like how long will it be functional till the total time, what is expected of it to actually work, whether it should be working only for the first 18 hours a day and the remaining hours it'll be on a silent job only basis or request only basis software, or it will have maintenance windows of 1 to 2 hours late in the night where customers are not going to use that system. So that availability has to be ensured, and how that needs to work through the quality aspect as well. Second comes security. So in today's world, anyone who has data is a target for any hacker around the world, or it could be any country which is trying to actually sneak out another country's information. So they have the security as one of the most priority ones of a quality aspect in today's world. And safety is another way of understanding how the operational or the functional effectiveness. You have given your data to somebody who is owning the product, and they have to safely manage how your data is managed, how your functioning, like the operational functional of that product is working with your data, how well and how they manage it, and how is the final product, or what is the operational efficiency of that product, and how well they actually have done to give you what you have used that product for. So that needs to be done in tandem to it. So that's why safety is also an important one. Next comes reliability. Availability was like when the product was functional over a period of time. Reliability is more in terms of when you have a catastrophic event such as a cyclone attacking the shores, whether the software would be able to function without any problem, and it will be reliable over a period of time. And say a cyclone is like more of a natural cause. Think of something which is kind of like a severe bug or a defect or some vulnerability which was understood from due to a security reason, and because of which the reliability of the software was nowhere. Next goes performance. So we want to have, in this fast-pacing world, whatever we want to learn about should be instantaneous. So we have today we have a WebEx or a Zoom. You want to know what is happening, and you want to perform certain operations on an online banking environment. You are trying to log in. You click on login, and you want an instant response saying that your account balance is this. You want to see that information instantly, and you want the software to work even though the load is at a maximum. Say Flipkart decided to launch a phone on 12 p.m. On Friday, and they expect every single user to use it. At the same time, there should be users who are able to buy that product. So it's not that they just access it, but they have to buy it. and lakhs of people could log in, and if they are not able to get that product, it becomes a customer nightmare, and customers trying to reach out for support, and they are not able to reach out support because the entire system goes down, because they are not able to scale to the need of the customers at that point in time. Next, let's see what became the traditional software testing, and how did we move to this quality engineering, and why this has come into picture. What's the difference between them? So quality engineering, we were saying that it stands with certain principles and it looks at certain quality aspects, and it will work as per the standards or the software requirement specification. So you get the software requirement specification, you will have to plan in a way from the start envisioning phase what is the requirement. So you just don't have this software requirement, you also have business requirement specifications. It doesn't stop with that. So you have to plan a strategy of testing process, as well as ensuring that the quality is not affected in any ways because of possible potential bugs. So you have a sense of quality sense check at every aspect, say from the unit testing aspect, from integration testing, component testing, conformance testing, so many other aspects, performance, reliability, and all that. And you'll have to ensure that everything works as per the plan that you had actually envisioned. If there's any deviation to the plan, we will see how we can actually handle that in further slides. And we were talking about how QE goes or spans across the entire product life cycle. So you are going to be just small teams, and you have envisioned everything into everything in the sense of quality in place, and you're checking towards that. And you also ensure the process of software maintenance, because you can't just launch a software and you can't expect that software to run without maintenance. So you need to ensure there's proper maintenance of that software, how we can actually improve the product over time based on the feedback that you get from the customer. So the main focus is quality control to ensure the requirements are met properly. Software testing, so this just validates how that application works. So we might have certain specs, and this might be more from a black box testing. So you don't know how the solution is being built, but you just see how that solution must work. So on that basis, you validate and you ensure that defects or logs, or you find potential bugs, and then you maintain them, you check them, you ensure that they are fixed, you validate them again and ensure that they are fixed and shipped to the customer in that possible way. So the main focus is just to test the application and find possible bugs which could crash the application. So that's the entire focus for software testing. So we all know a software bug could be on any level. So this is just a definition which you can pull out from anywhere. I've pulled it out from Wiki. So software bug is an error, flaw, failure, or fault in a computer program or system that causes it to produce an incorrect or unexpected result, or to behave in unintended ways. So you define certain things and it behaves unintendedly, then you definitely have a bug. So what kind of bugs or what types of software errors that you could actually look at today in today's world? One could be functional. So functional is the core basis, and we will see the other bits of how we are going to separate out functional and non-functional, but let's focus on the functional bit. So the functional bit could be more from a requirement, business requirement perspective. So that there's software from a solution level perspective. Business level, they would say, I want to have this operation performed when I click on this button, and this function should perform another function at this junction of time once this process is complete. It fails at each of the functional change which is applied based when the user clicks on some button, it doesn't work, or that function doesn't communicate to another function, it becomes a failure on that case. Communication errors. So these also become software errors, wherein you prompt to a user and user saying, okay, fine, I want, tell them the operation that he has performed as created in an unintended job, and we should notify the user saying that you have done something wrong please revisit your journey, or this is something and we have reported it to ourselves, we will get back to you. Some kind of communication should be there. And if we don't do that, that becomes a software bug as well. A missing operation. So you've intended to a user a step of definitions for them to follow and perform certain operation. If they have not done so, or if that operation is not, so you have given them 4 steps. Out of that, they were able to perform 3 steps and they messed out the 3rd step. It becomes a missing operation, and that is a software bug. Syntactic issues. We saw about how the NASA problem was related to metrics. So understandable metrics or incorrect sentences, grammatical errors, which could lead to a customer to do something which is not the right way. So that could be a syntactic error. Error handling. So a customer faces an error on performing an operation. Say they have logged in, the login has failed due to your password mismatch. But this error handling, if understood as a understandable message, say you are providing him with a code saying error 001, the user will not understand anything of that bit, and he will try to reach out to the customer support, telling about the codes, which will not help the customer. But if you're going to give them a specific reason saying that the issue was related to your wrong password, and they give you a specific timeline or error code stating that this error code will be of this particular problem, you can revisit, or you can check the support, customer support, or the FAQs, frequently asked questions, to understand more about this issue. Next comes the calculation issue. So we've already touched base on the calculation type mismatch, or like the error, like the metrics mismatch, which we talked about. What happens if there are 2 different types of metrics the system cannot understand? That becomes a logical issue, or like more of a error in terms of the logic by using different metrics. That will make sure, that will definitely cause issues in the long run, and it'll not make sure it performs the operation that it's supposed to do with the actual. That's one other thing. Flow. So I'm expecting my user to perform an operation step 1, step 2, step 3, and step 4, but the flow is being hindered, and the customer is taken from step 1, step 2, and he's taken to steps rather than step 3. Then we have generated using the business logic. If we have identified this at the earlier stage, we would have reverted back to the business developers or the business analysts, and they would have come back to us with what should be the operation that we were supposed to do. If it was caught earlier, it would have been an easier fix. So in today's world, what are the recent software development trends that are in place, and why it is booming? Because of this fast-pacing world. So we have something called as progressive web apps. So more similar to web app and a mobile app, and it uses APIs for getting instant informations. Next is continuous in delivery and deployment methods. So they use a software in shorter cycles. So I was talking to you about how agile and shift left has paved the way for faster deployments, or or the vice versa, wherein faster deployments has made sure that we have shifted left in and introducing the quality engineering and all aspects of development. So this is paved a way. AI driven. So there are projects wherein it learns about the user experience and gives you suggestions, kind of like how Facebook does. You might have booked a ticket to someplace in Delhi, and then it gives you learning how your actions, or you receiving your ticket on your Gmail. Facebook would know that and give you some suggestions saying that you can go to Delhi, visit Agra, visit some places. So these are all AI driven machine learning. So they learn something from what they have collected without you knowing, and then give you some suggestions on it and promoting their product in that way. Immersive technologies. So if people are interested in gaming and in virtual reality, this has been in the talk of the town now, with mixed reality, to see how they use it to define a product, to design a product, say automation of different cars, how they have developed, and how they can actually view it in virtual reality to see the position of the steering wheel, the position of the buttons, how well it is for the end user to use it. And they do that with immersive technologies, games with virtual reality, 3D, 4D. You have so many other immersive technologies that have come into play. Now, distributed cloud services are picked up. So we had Amazon Web Services for a long time running most of the cloud services. But now we have bigger players like Microsoft, who has pitched in with Azure. We have Google Cloud, and you have other providers as well who are trying to spread out on geographical cloud locations, providing the products and benefit for the end users in a quick span of time, reducing the response times, reducing the time that it reaches, and how the products are available over the period of time at 99.999% availability. So where do we apply? So we know something about quality from a testing principle perspective, but where can we apply if we have known the issues well ahead when you are designing the solution? So you have a software developer, and he has been experienced in software development for over a period of time. And when the solution architect is trying to explain, he would have seen it from purely from a solution basis. You wouldn't have seen from technology perspective. And the software developer who understands how or where apply, what kind of language I can use, how I can actually improve this product. He could give suggestions saying that, okay, you have said the solution here, but using this particular language, we might have certain limitations. It's better to go with a different technology. So they might give you certain problems beforehand. Java, using Java and using Node.js or like JavaScript, which is better. So they could improve that aspect at every area, and they might also involve the quality trend to it, telling that if you are going to use uh, JavaScript, there might be an implication that you might get your results much faster, but there are problems with object-oriented um, designs wherein it might not be applicable well enough using JavaScript. Rather, you can use Java or use TypeScript or a different language altogether. So this is something which I pulled out. So Christopher Crawford mentioned, knowledge without application is like a book that is never read. You would see the cover, but you would not have read it, and you would not know how to apply. So application. So from testing guidelines, you have functional defects as well as non-functional defects, or the functional area as well as the non-functional area. Functional area covers, it should cover what it should do, what should the application do. Non-functional should cover how it should function, how should it perform, what is the speed it should provide the result in. So those kinds of things are catered out through the non-functional bits. So just differences between them. So earlier functional bits and non-functional bits, they had different things to do. And you can now do both functional bits manually and or using automation, and similarly non-functional, you can do it via automation. So this is just a simple thing. So to understand in today's world where should we use a quality analyst, where should we use a tester, where should quality engineer come into play, the quality analyst is kind of a person. So sometimes these three terms are misinterpreted, misused, but there's quite a nice difference between them. So I've just put it up for you for your future reference in case you want to go back to it. Quality analyst ensures that the product or process in the software development cycle comply with various standards. It just looks for the process in the product development. So to ensure quality processes are in place. And tester just involves whether he looks at whether the functioning of the product is as per the requirement, and he doesn't look in any other aspects. He would not even involve himself in the quality process unless it is being intimated by the quality analyst. If there's no quality analyst, the tester's functioning would be limited only to the bugs and only to the errors or defects that he has taken from testing. When you take a quality engineer for that matter, he uses not only from a quality or a product quality, products ability, as well as like the bugs or software or the software issues that we are being found. He doesn't worry just about that, but he also introduces engineering practices that he has learned so far in different phases of software development, applies at each and every step. And he also should be aware of the new techniques which are available for security, performance, and should be aware of the continuous deployments and delivery, because these are coming into play because of the agile development that we have on the frequent faster deployments that we saw earlier. And today, the quality engineer is being focused as a software developer engineer in test. So what does he do? So how does he filter into this aspect? Because a software developer understands the in and through of what coding he has worked on and what he has done with the code. And earlier, the tester was only focusing on the end product and ensure the quality. Now, the software development engineer will look at it from a testing and quality perspective, tell them where all you can improve the code, where all you can face and change the way that we have deployed. Say, I've used a different style of coding. If I've introduced certain rules that ensures the quality is in place at a very early stage, every developer who's working in his code, when he checks in his code, that code will cater to meeting that standard. If not, that code gets rejected and that quality is not met. There could be open-ended statements. There could be some errors which had happened, which should be missing, and in case that developer goes away and some other developer comes, that person might take a long time to understand what the code was all about. So you ensure that at every aspect of development. And he would introduce in like we saw in the different quality standards that we saw earlier about the 5 standards on reliability, performance, security, and so on and so forth. And estate should be aware of the entire system. So without knowing the entire system from the envisioning phase, if a quality engineer is put in place, he might be able to help out, but it will take some time for him to understand how the process has been evolved, is being done in this current project, and how we can actually improve it only after he sees some outcome. He can't just come in and just change the way the product is being working on. So estate must be involved from the initial envisioning stage, from when the solution was actually or idea originated. From that point in time, if you actually include him, it is better. So this is how what we do and where we all put our details to improve the quality in. Incubate is just a session, usability, different kinds of things that you can actually look at and where you can improve, how you can actually cater to defect logging, how you can improve the process of defect logging, how you can improve the process of defect continuous execution, how you can improve it in delivery, what kind of automated tools can you use, how can you reduce the time to improve the way that we deliver the product, how we could reduce the timeline for the release of the products. So all of this also plays part of the quality engineering perspective. How do they do it? So they define an approach. So you might hit it the first time if you're lucky, but if not, sometimes it might be on a different level, wherein you learn from the outcomes, you refine the process, and you continuously improve the process of doing it, and then it becomes easier for you. And when you go into the next project, or when you go into a next feature that you are building, it becomes much easier. So the QE process involves all of this together. So analysis, testing, improvement, management, development, customer feedback. So we saw how it has shifted during the World Quality Report, how customer satisfaction has paved a major role. So it's one of the requirement for a quality engineer to also understand what the customer feedback is, how he has used it, how he finds it usable, how well it is, and he collects that data and then he starts planning again from the initial phase, or he can improve it in the later on. So what kind of responsibilities does a quality engineer has? He has to set up standards, certain parameters, say I want my code to perform in such a way. Once my product code has been checked in, it has to be reviewed by at least 2% on peer review. Once it is done, I should run X number of test cases, unit test cases. Once that unit test cases are passed, it should run in X number of integration test cases. And I also should ensure that the quality of the data that is being provided from the unit test case and should the integration test cases, they match and the data metrics are met. All of this can be defined in the standards and the parameters, what kind of data I should be used, and only then the product should be shippable for the next environment for testing. Next, collection of data. So you collect the data that you have seen, you analyze the data, and I think business intelligence is part wherein we learn about the customer usage, but here it's more from a product's behavior over a period of time, how those data points say I have certain number of defects in a specific area, how I can reduce that specific defects in that specific location or specific functionality. I need to understand and analyze it, and then build appropriate tests to avoid that defect being occurring at a later stage in time, rather than catching it much earlier, fixing it at unit test phase, and building a better product on that initial phases. Then identify that issues, find possible solutions. So if I think my way of reviewing a code is not helping the quality of the product, I must find a way to improve that product to have an automated. I check in should check if there are open end statements, if there are like code errors or syntax errors, and it is not functioning as per like if there are any typos. All of this, if it identified at a very earlier stage, then I can refine that process if it's not working with another process. So that's how they do it. So they collect the data, they start providing or improving those solutions. Then they generate a plan, apply it using different tools. So we have multiple tools. It's not just one tool that we are going to look at. There are plenty of other tools, open tools, as well as like paid softwares that are out there, which ensures quality. And this usage of tools might differ from organizations to organizations, from companies to companies. So we'll have to be sure if it's going to be a defense project, they might not be happy to use an open source tool. So they might want you to do paid softwares, and they might also want you to have closed loop tests wherein you are doing it in utmost care that nothing is leaked to anyone outside. So those kinds of things are to be taken into consideration, following up to ensure the issue has been addressed. So once everything is done, the outcome has to be studied, and you have to see whether the feedback or the outcome is as you expected. If it is not, is there a way or any process of improvement that I can apply? So it's more from a learning perspective that you will do, and you will evolve your process over time, and it becomes really strong, and your product is utmost top-notch quality, so that you don't see any defects in the long run. What are the ways and what are the toolings? So currently, most of the big accounts or the big software development industry is now focusing on these tools for maintaining their resource documents or requirements. Confluence is one tool wherein you can put every requirements in it, and everyone can simultaneously access it, kind of like what you do with your Google Docs. So they also integrate with an issue, so you can log an issue on a different thing like ALM, which is a defect tracking tool, or a Bugzilla, and then you link everything back to it, and it's all linked in your system. So every tool can be linked. So this is by Atlassian Group, most of the tools, and many of them have their own plugins which is linked to them. So which gives us a better understanding of how we can do. And what I've got on the right side is the open source tools which I've looked at for the same operation that is being done with the paid software. So Atlassian Group is a wider use group, and it is being a paid software. So you also have other opportunities which are also being used by other projects. Next, so we saw security is come into the forefront and how I can improve it. So I'm writing a code, and what should I do to ensure that the quality of the code? So I'm not a supercomputer to understand every issue by just looking at my code. I'm my lead analyst, or somebody who is more senior. He might understand an issue and he might capture it. But at times, if 1,000 or like say 5 or 6 people develops a code and hands it for peer review, and that person might be overloaded, he might not be able to find out what kind of gaps that code has. So we came to the usage of tools, which does most of the work for us, and then we identify those solutions, we categorize and we prioritize, and then we look at ways to actually improve the way we do it. So source code analysis, SAST and DAST, dynamic application security testing, source code analysis, security testing. These are tools which have static application testing, security testing has come into play, wherein it compiles the code for you. It tells you where your security flaws are, and you don't have to deploy the code instantly for SAST. It gives you, like, on a specific piece of code, you can get that report instantly. So that is why static tools are used. Dynamic is kind of like the runtime environment, wherein you run the entire application, or like you run a simpler component, and then Dast examines it for you, and then it tells you, okay, fine, this, if you have, is a vulnerability and it could be accessed by somebody outside and they could attack it, and you can better handle it with a few suggestions which the Dast tool might give you, which you can apply, or you can take it back to your security specialist. He might study and he can give you inputs. Penetration testing. So we're not aware how a hacker actually hacks into your systems. We generally use firewall. We use some antivirus to protect ourselves from attacks. But what if the tool is being hosted elsewhere? So you sit in your laptop, you're using your online banking tool. You're not so sure how your data or information can get hacked. But the penetration testing, if it is done at an earlier stage, gives you, there are plenty of tools that you can use, or you can hire some specific teams which actually ensure that the security is top notch, and they give back results to you, wherein you can prioritize, or you can talk with your security experts and come back with any issues, and they can actually take it back, and then we can correct that code in a different way, or they will give you suggestions wherein you can actually look at. So similar way, the tools also we use, Wireshark, Nessus, Zap, which is Z attack proxy, or Zap, which is another tool. So as we develop the product itself, you can run these and you can get the reports, and that limits the time that you do the analysis, to you hire somebody to do the test. So you can do it well ahead in time. Once you have completed your code, or you have checked in, you have set an automation process wherein it runs Z proxy, identifies the issues for you, and then tells back. You can improve this process by revisiting your code. Using this sample, you can improve your code in a different way. Next comes performance testing. So we were talking about how today Flipkart launches a product at 12 p.m. What becomes a problem? Many users using at the same time, they might have problems. So you have lots of performance tools, wherein consider something like NASA is going to launch a rocket, and they want instant results, and they can't wait for more than 1.5 milliseconds. And if you have identified that while coding that your loop which you have used, say for loop or if loops, whatever loops that you have done, a while loop, is taking more time, or it is going to an infinite loop, because of which at some point in time it gives you a result for one particular journey at 2.5 seconds, which is a breach of what NASA expected you to do, which was only 1.5 milliseconds. That will become a problem if it was identified at a later stage, because the rockets cannot just wait for you. You have launched the product, and a particular point in time, it is expecting some release for a part of the rocket to fall off, and it is just holding on for 2.5 seconds rather than 1.5 seconds. It could burn the rocket entirely, and the entire project could be wasted. So similar kind of things can be identified at an earlier stage if you use certain tools. So you can the browsers today have come up with their own developer tools wherein you can study the performance. You can see what happens if there is a slow connection. What happens you have a 100 megabits connection? What happens if you have uh, something which is 2G? What happens if it's just 3G? What should be the behavior? So you can use certain browser tools as well to ensure your performance is up and state of the art. We have Taurus, which is open source, Artillery, which is open source. BlazeMeter has certain principles wherein you can use and log. Next come automate testing. So gone are the days where manual testing was kind of the talk of the hour. They believed that everything could be done. But consider you have 4,000 odd scripts which has to be run as regression for launching a product or launching a small change in your product. Just a small change of introducing some few texts or a new page in your software. You want to execute all 4,000 scripts manually. It's going to take you ages. Rather, if you have automated testing, which says, okay, fine, I will run the 1,000 scripts tonight. I can come and check the results later once my test is complete. Or once I build my project using Jenkins, which is a pipeline deployment tool. So for continuous integrations, we run certain jobs. So those jobs could have automated scripts, and those scripts have to run 1,000 scripts or like 500 unit scripts and tell you that your component which you have introduced is not affecting any other components. All of your integration tests have completed successfully when you come the next day. You don't have to look manually for each and everything. So now automated testing is at most peak. You have different tools, different frameworks. Selenium was there ages ago. Now it has evolved. There are plenty of Selenium frameworks using JavaScript, Java, Python. You have many languages, and you can actually build frameworks which does what you need. Sometimes now most of the apps are like progressive web apps, because of which the Selenium frameworks have taken a big boom. But earlier we had all of these Windows applications, small applications which runs on your server, Unix based applications. Sometimes those also can be automated using Ruby, which is Ruby on Rails. You have other tools such as UFT, which runs on applications, Windows-based applications or Mac OS-based applications, standalone applications. So you can use different. Tosca is another tool. So Selenium framework is more open source, so many people can try and use it. So it's quite a wide framework, and you have plenty of forums where you can actually talk through. Next comes usability. So customer is more trying to tell you how he felt about the application. So when you do usability testings, so some are alpha tests, some are beta tests. So you give certain journeys for the user to do it. So what banking sector currently does is, before launching a product, they invite people to come to their secured locations. Before launching a product, they might be relevant business partners or people or relevant customers who would be using that tool. So they would just tell them, they will just give them and call for them to come in, and they would give them a piece of paper wherein they would see the steps. They will ask them to perform that operation. So when you're using the tool for the first time, you might find certain problems with the color. People might find it, okay, fine, if this button was green, I would have clicked it, but this button was in a different color, I was not able to do it. So, and or you ask them to perform 4 different operations, and the person is stuck with the second operation, knowing not what to do with the next step. So if that's the thing, if you have launched the product well ahead of time, you would have faced a major problem where everybody will be getting stuck at the second step. They would not be able to proceed to the third or the fourth step, which would be your final result, and which would be kind of like, say you're applying for a loan, you have 7 forms to fill, you have filled only the 4th form, and you're not submitted the form, and the customer is going to lose interest on applying for a loan, and they are going to find another person who is going to give that loan in a well limited time. So you just click certain screenshots, apply it, and that loan is going to come through. So they also study with different other products. So the UX research methodology is like not stopping with just customer research, it also involves product research. So you might have different competitors of the same product, but you might have a new idea that you want to introduce. What will the customers think of that idea? How I can improve that idea in a way. So you can give them on it, and then you can ask them to perform it. You can have a live testing, and you can guide them. You can tell them the steps, see if they are responding. If not, you can ask them, what do you think, how we can improve this product, and they would give you. And you take the concerns of all the reports that you have collected, and then you evolve the product to actually make it better. Next comes risks. So I think Engineer Emma covered this risk management, but I'll just give you a bit which we use in our project. So we use something called as a scaled agile, and we use something called a SAFE framework. So it involves how the risk is managed with 4 possible simple terms. One is resolved, one is owned, one is accepted, and one is mitigated. Resolved is like you've identified one of these 5 risks. Say you have identified a budget risk, you have resolved it by applying for a committee, telling them that if you're going to introduce this product, the result is going to be really enormous, and this is the research, and you have valid proof that this product will function really well, and you are going to get back the money. The stakeholders who are providing you with the money, they might think, okay, fine, let's give them another package to improve the product still further, to make it much more better. So that budget risk can be resolved in a way. What if you are coming under technical risk? So you find there is a problem with the performance, and you identified a certain performance expert who comes and tells them, okay, fine, the query that you have written is taking 1 hour to perform. If I say that, if I give you certain insights, I think this query could be reduced to just 30 seconds. From 1 hour to 30 seconds is an enormous change. And if that risk is being given to somebody and given him the ownership, he will own the risk, and he will ensure that it is being resolved at a particular point in time. Some risks can be accepted. Say you have some programmatic risks. So you have external risks. Say, for example, you are using some node packages in JavaScript, wherein you are using some node packages, and there are some known vulnerabilities which you are aware of, but you don't want to fix it because it's not going to help in any way, because there's a new version coming, and you're going to launch the product with an older version, and you definitely know that that risk is going to be mitigated with, or which is going to be resolved once that new version is going to be in place. And you're not going to change your entire architecture just because of this known vulnerability, which is just a low risk, which is not going to cause any major problem to your customer or to you or to the reputation of the products product owners. So then that risk can be accepted and it can be maintained. So none of these risks should never be omitted. Rather, it should be recorded and maintained. Next is like how we can mitigate those risks. You identified it. What kind of precautions that you can do, or what kind of way that you can improve in a way to avoid those risks, or way to solve those risks, you would ensure those plans are in place. So this is something from the safe agile framework. If you have plenty of frameworks, so this is something which was really useful for me, and it has helped our project in a significant way. So I've given you some ideas, insights into it, and I believe it is covered much more in detail in the previous seminar that you attended. There are a few other things which I would bring to your notice. One is resilience testing. So you have currently cloud hosted apps, and you want to ensure that the cloud hosted apps have a proper failure mode, or you have encountered a failure, how we can actually resolve it, how fast it can actually rework or restart to begin with. So all of this needs to be tested beforehand before you launch the product. So you made a change in the architecture. You have known that you have changed certain things, and this would improve the way that the restart of those missions in the so the software applications using virtual machines will pick up this much time to restart. So you understand all of this before previously testing it. So you do a pre-live test with limited users, or you use it like when there is nobody. You test the entire resiliency of the software. You conduct critical tests, say, okay, fine, what happens if I do a payment, and what happens if the entire system falls down? Whether my payment, which was supposed to go through, is in a queue, and once the system restarts back, the data is not lost, and it picks up from the queue, and it goes in an orderly fashion from what has reached in first in, and it should go as first out. So whatever it has entered into the queue, it has to go through. So all of this is covered as part of the software resilience testing. So what we do, how we can actually do it from a single region. What happens if you have a catastrophic failure? See what happens, say you have used Azure as a platform to host your product, and you are in 3 different regions, one in North America, one in Southeast Asia, one in Africa, and suddenly your North America server is down due to a crisis there, or what happened if a network cable is cut. So immediately it spools up in a different region. It gives you minutes, or it could be even seconds. Sometimes it could even take hours. So you have to study that to ensure that your end users will not face problem. In case what happens if if it is going to be a 1 hour block of a critical business, say share market crisis. So you have a problem wherein shares cannot be sold or shares cannot be bought at that 1 hour gap. Your customers are going to lose a lot of money. So in turn, what you will do is you will build a system wherein it actually spools up another system, or it diverts your traffic from North America to another other system, which is like in East, like in United Kingdom. Rather than US, it used South America or UK, wherein the system is not affected in any way. All of that system has a backup, and it starts instantly without accessibility testing. So I'm not sure that this is being widely used in India as of now, but when it comes to countries which is kind of like US and UK and Europe, there are certain laws for the governments to introduce certain help for visually impaired or people who have disability, who need to use a software application. So they might not have proper eyesight. They might have to use and perform certain operations. To benefit them, they introduce certain standards. So those standards have to be met for any banking community or any government oriented sites. They have to perform certain operations. So we all know about our Facebook. So why do we blue color? It's just because the founder of the company cannot see colors green and red, because he's colorblind and he is used to blue, and that's why we have Facebook primarily in blue color. And does it affect anything? So you have certain contrast issues that you might face in your websites that you had seen. Say for example, we have a button which has red letters, and you have a magenta button background. So you might not see the color contrasts clearly, you might not see the buttons, you might not perform that operation just because it's in a different color. And for a person who might have disability or visually impaired, or he might have problems looking at it, or he might be even blind, so you have certain ability for an so we all use our mobile phones, we all use our laptops, so there are certain accessibility options which you can enable. So it will read through the texts for you, it will tell you you are in input field, enter your name. So those kinds of information is tested well before for even the vulnerable customers or visually impaired customers or disabled customers, to ensure that we also give them like the benefit to use our product, and we don't lose on the operating margin, as well as we do not incur any huge slabs of fine from the government telling that we have omitted this group of customers. Next comes compatibility testing. So accessibility testing, we have certain tools, we have open source tools, we have certain automated tools. You can use some of the tools which I've given. Compatibility testing is another basis wherein you can introduce certain standards that I want my product and all platforms, say Apple, I want to use it in Android mobile phones, I want to use it in iOS, I want to use it in a different system or version. So if you define certain things and it should work, the World Wide Web standards which they actually introduced, telling them, okay, fine, if you have used HTTP 5, it should have CS3, and it should also have a corresponding way of using the logic in a different way using TypeScript or whatever be it. You have to ensure that quality is met in the compatibility region as well. Next comes backward compatibility testing. So backward compatibility testing is a need in today's world, because like we see that you have one version of the software being deployed into life, and suddenly you encounter a problem saying that because of my backend update which I had done in the previous release, the new version which I deploy will not understand the output or the input which I give to it. So due to which my entire system will be hanging in a problem. So what they generally do is, we also test n-1, n and n+1 versions of the software. So this could be validated, testing the components communicating with each other. So they would test whether the modules, different modules that I've developed, communicate with each other, and the different stacks that you have, like the front end, the middleware, and the back end, communicates on all three versions. So n-1, n and n+1, it should work without any problem, and it should work seamlessly. So this is also validated at backward compatibility testing. Next comes risk-based testing. So what happens if you encounter a huge catastrophic failure? Say you have a huge downtime of the entire Azure service. What can I do? How it will be impacting? So those kinds of critical risks are targeted or pointed out. So we talked about risk management, wherein you make a note of every risk available, and then you prioritize it. So then you say, okay, fine, the severity or the priority of that matter of risk is really high. So what should I do? I can base my testing or base my code or product using that critical functionality, and ensure whatever happens, say I have Azure, I also have another platform, Google Cloud, it should switch to this and that without any problem, and it should seamlessly work with a risk-based approach. So they find the highest risk problem causing issues, and they ensure, in case there is a failure, what should be my behavior, how should I handle that, how should I impact, how should I avoid that business impact. All of this has to be done via the risk-based testing. Next comes conformance testing. Say you might have, so you are working for Microsoft and you have a certain code principles that you want to set up. So you have a prescribed standard of APIs that you have developed. So those APIs which communicate with another system, incoming or outgoing, whatever be it, it should be of a prescribed standard. And if it is not, you should call out at a very early stage telling that it is not meeting this organization standard. What should I do? So this also fall under the quality engineering principle or process, wherein the quality engineer intimates to the organization level, telling them that whatever changes that you have implemented is affecting your prescribed standard which you had implemented in the year. Okay, so they can tell them that, okay, fine, in for several 10 principles that you have, standards you have set up, it is failing in standard 2, and then they would definitely go back and improve the standards, or they would alter the standard to meet a certain acceptable level. They would accept it, or they would ensure that it meets the standard and rework on that particular thing. So you have much more, but all of this encapsulates that we shouldn't overdo it. So if you're overdoing it, it will not help either. So if you want to do all of these testing together and you're going to launch the product, which was supposed to launch in January this year, if you're going to launch the product in January 5 years later, it's not going to help you. The business is going to be fastly evolving, and you might lose that market margin, or like the operating margin for that specific year, and you're going to lose the entire customer base on that product. So it is also the quality engineer's insight that he should be taking extra precaution to ensure that there is a timeline which is being met, and it also should be met with these quality standards and principles, but ensuring that the quality is top notch. That's foremost, but ensuring that we do not delay the product launch in any way. And if you have any questions, I think I've come to the conclusion of the topic. So if you have any questions, you can post it. I'm looking at, okay. There are no questions.
So far, no questions. Participants, if you have any queries, you can post in the chat box. Otherwise, you can unmute and raise the question.
I think there is a question from Raj Kumar regarding testing related to machine learning. Machine learning is, I would say Python is more of an open source, and you have brilliant forums, and you have lots of machine learning packages with Python. So it is always better to use that, and it is kind of like an evolving language as well. So you have plenty of new packages and forums which are working towards it, and it's talk of the town now. So I would suggest that. Okay, there's a question. If a software does not meet its quality, who among these is more responsible? Either it's the software designer or developer or software tester. I would say the entire team would be in at fault, because a quality engineer paves the way, and he ensures that the quality is at every stages of development. So we should ensure that not just him, the entire team is responsible in this case. So they will have to introduce that every aspect of quality is met, and if it is not met, then they would learn from it, from their failures, and they would work on it. Thank you. So there's another question: what is regression testing? Um, so regression is in terms of you have built a new piece of package to your existing software, and you have a banking software and you're just introducing a new thing. Say I want to introduce SMS text messages for any payments that I've done. I don't have to test um, just that bit, but I will also try to introduce or test the core functionalities of my banking software. Because of introducing this text message, which gets the information from my database of the phone numbers, pass it on to some other code which handles the messaging service. That messaging service collects it and sends it out to the end user who is using that mobile or who is using a device. So at that point in time, I want to have a complete coverage of all the critical functionality which I had actually worked on, or which I have, so that I don't break any of my previous functions or functionalities. So that is the reason behind it, and that is more in terms of regression.
And there is one more question.
Yeah, I'm looking at it. How the loss is taken back, whether the team or government. So it depends on. So say Lloyd's, I would bring an example. Say Lloyd's is a banking group. It's a big banking group, and the government decides, okay, I want to introduce certain rule of how you use your open banking, or like how you use your online banking. So they have introduced this, and they set you a date saying that with April, so consider, okay, July 30th something of 2020, I want this particular change should be applied to all banks, Lloyd's, HSBC, or any other bank that is in the operation. If we fail to launch that product, it becomes a conformance issue with the government level or with the financial sector level. So the loss has to be borne by the development authority or like the product owners. So consider Lloyd's product is an online banking tool for business customers, and if we have failed to do it, then Lloyd's will have a reserve, a risk reserve, telling them, okay, fine, this is for my litigation. If there is any problem, for fines or anything which I have to pay back to the customer or pay back to the government, they will have a reserve and they will pay back from it. But the team which had worked on it, they would be they would have done their job really well. And if they had actually missed out an opportunity, it is always an opportunity for learning, and they have to counter it in the next time, or they might apply for an injection telling them, okay, fine, we have implemented this, but we find there is a gap in the document or in the request that you have provided, and they can go back to the government or the financial sector and tell them, can you evolve this product to meet or give us a new deadline wherein we can do it. We want to give a better product for our customers without affecting this. So then they would go back and do this. Hope I've answered. Anything? That's quality of software, quality of physical product is similar. I would say it could be different in aspects, but you can apply the same quality engineering principles to ensure you have a better physical product as well. Say, for example, you have a car, you can do have I covered validation and verification of a software? Just a minute. Validation and verification. Just not top of my head, but let me give it to you. Yeah. Validation, it's from a customer perspective, and verification is from a software, a code perspective, if you could say. So it's just meeting to your, so you have a specification or requirement specification or a business specification. If you are validating to meet it, it's more from a validation perspective. Verification is from a software coding perspective that you want to identify and mitigate or fix it. Hope I've answered. Anything else from me?
Okay, if there are no more queries, then we can wind up the session. I request Swatika to give a vote of thanks. Swatika,
Ma'am. Yes, ma'am.
please.
Okay, ma'am. Yes. Good evening to one and all. First of all, I would like to thank the resource person, Engineer Paul Wesley, Test Lead, Oracle Technologies, UK, and he has explained various examples of fails very clearly, like why the project fails, how can we handle the error, what type of data we can store, and what type of privacy we can include in the data, and what are the tools to detect the quality. And he has narrated various quality attributes as well as what are the differences in quality engineering and software testing. And he has clearly explained what is the role of quality analyst, quality engineer, software tester. Really, he gave a detailed talk on quality engineering. So his talk was highly informative and very useful to all of us. So on behalf of our institution and Department of Computer Science and Engineering, I wholeheartedly thank the resource person for his valuable speech. Thank you, sir.
Thank you. Thank you so much, ma'am.
Thank you, sir. Thank you, one and all. Thank you, participants.
Thank you, everyone. Thanks for being part of it.
Thank you, Wesley.
Thank you.